Hello, my dear students. This is the second and third part of the uh, Unit 6, Lesson 4. What are the planets in our solar system? Last time we finished the inner planets. This time we'll be talking about the outside track, which is the outer planets or the giant planets, and the life zone of Earth. How is it suitable for life? So we will start, of course, this page is 334. So we will do 334, the outside planets, Jupiter, Saturn, Uranus, Neptune. We have the right spot, which is the Earth zone, talking about the Earth zone. We will compare Venus and Mars. Then we'll finish the lesson. Okay? Now, let's go back to the digital lesson. Outer planets. Listen up, please.
The asteroids in the asteroid belt orbit the Sun. Beyond that are the outer planets. The outer planets are much larger than the inner planets and are made mostly of gases. Because of this, the outer planets are often called gas giants. Click the dots on the line to learn more.
So they're called gas giants or the outer planets because they're made mostly of gases.
One of the most famous features on Jupiter is the Great Red Spot. Astronomers have discovered that this is a huge rotating storm. The outer layers of Jupiter are made of gases, but the center, or core, is thought to be a solid. This core is surrounded by layers of liquid and then gases. Jupiter has more than 60 known moons.
So the outer planets, they have small center, or it's called core. Then, so this is the core. Then the other layer is made of liquids. Then the outer layer, which is the surface, is made of gases. All of the outer planets. Next, Saturn.
All of the outer planets have rings, but Saturn's rings are the easiest to see.
It's obvious.
Saturn rotates very fast. It rotates all the way around its axis in a little more than 10 hours. Its atmosphere is very windy and stormy. Saturn has more than 60 moons.
In general, the outer planets have shorter daytime comparing to the inner planets. For example, Earth daytime is 24 hours, while Saturn day is only 10 hours because it moves very quickly on its axis, or it spins quickly on its axis because it's made of gases that make them it makes the planets move quickly because the gases have less density than the rocky planets or the inner planets. Now Uranus.
Most planets have an axis that is almost straight up and down compared to the planet's orbit.
This way.
But Uranus is different.
Uranus
spins on its side as it revolves around the Sun.
This way.
Almost as if it is rolling along its orbit. Uranus has at least 27 moons.
So Uranus moves like a rolling ball on its axis this way. It's unlike the other planets.
Neptune is the farthest planet from the Sun, which makes it very cold. Neptune is one of the windiest places in the solar system.
And windiest.
Neptune has at least 13 moons. Some of its moons actually orbit within the planet's rings.
Now, the last
Until
one.
2006, everybody called Pluto a planet. In 2006, however, astronomers decided that Pluto is really a dwarf planet.
Dwarf planet.
A dwarf planet orbits the Sun along with other objects in the same orbit. Dwarf Dwarf planets are also smaller than planets. Most of the dwarf planets are found beyond Neptune.
So it's a dwarf planet because it is not as big as the planets. It is smaller than the planet, and it is larger than asteroids. In addition to, its orbit around the sun is not clear. So this is why it is classified or considered as a dwarf planet. Next.
Some planets are called inner planets. Some planets are called inner planets. Some are called outer planets. Drag each image into the correct box.
So inner planets are closer to the sun. They have rocky surfaces. They have more density. While outer planets are made of gases. They are farther away from the sun. They have small core comparing to the inner planets. Okay, let's classify them. Inner, it means they are very close to the sun. So we will start from Mercury is the first one. Then Venus, the hottest planet, although it is the second in order because of the heavy atmosphere which is made of CO2. Then we have Earth and Mars. So all of these are the inner planets. Now outer planets starts Jupiter, Saturn, Uranus, Neptune.
That's right.
You can do it on Think Central. Open your account, you can do it.
The inner planets and outer planets are quite different from one another.
Okay, here we will compare the inner planets and the outer planets according to 5 categories. 1, diameter, which is the size. 2, movement, how do they move. 3, composition, the component. 4, the atmosphere, which is the layer of air around the planet. And temperature, which is related to the position of the planet. Let's start with diameter.
The outer planets have much larger diameters than the inner planets. For example, Neptune is almost 4 times bigger than Earth.
Yes, now let's see movement.
Like most of the planets, Earth's axis of rotation is almost straight up and down compared to its orbit. However, Venus rotates in the opposite direction from the other planets, and Uranus rotates on its side when compared to its orbit.
So Uranus rotates on its side, while Venus, this one, Venus, rotates opposite of the way the Earth rotates. Okay, so on Earth, the sun rises from east, while if you are on Venus, the sun rises from west. Now, let's see the atmosphere.
The atmospheres on the outer planets are very thick and very stormy. The inner planets have atmospheres of varying thicknesses. Mercury's atmosphere is very thin. Venus has a very thick atmosphere. Earth's atmosphere protects life on its surface.
The last one, temperature.
The inner planets are closer to the sun and have higher temperatures than the outer planets.
Yes, the inner planets, they have higher temperature, while the outer planets, they have lower temperatures because of their position.
Earth is the only planet known to be home to living things.
Now, we're in part 3. Part 3 is talking about life on Earth, and this is called the life zone, where Earth orbits the sun. We have 3 reasons why Earth supports life. Okay, so 1, 2, 3. Let's listen to the slides.
Earth is 1 AU from the sun. This is equal to 150 million kilometers, or 93 million miles. Because Mercury is so close to the Sun, daytime temperatures rise much too high for living things. Jupiter, on the other hand, is so far away that it is very, very cold. Earth's temperatures are just right for life to exist.
So this position is helpful for the right temperature for life on Earth. The second reason.
Earth rotates or turns on its axis every day. This causes day and night cycles. During the day, plants use the sun's energy to make their own food. Animals and other living things then eat plants, or other living things that eat plants. So, in a way, Earth's rotation makes life possible all over Earth.
So Earth rotation makes life possible for all of the Earth. Now, there's something very important I have to point out. The axis of Earth is tilted in a certain degree. This is very important. It is not straight up and down. Okay, the angle is very important for the right temperature.
Earth's orbit is almost a perfect circle. This means that Earth is always about the same distance from the Sun. Because the distance doesn't change much, Earth's average temperature doesn't change a lot from one time of year to another. Of course, the tilt of Earth's axis gives us seasons, but the average temperature is just right for living things.
So the Earth revolves or orbits the Sun in a circular, almost circular path or circular orbit that is very suitable for average temperature to be the same. Okay, average temperature, I mean in winter and summer, it's almost a good temperature for human to stay alive. Next.
Look at this image carefully. The 8 planets in our solar system can be divided into 2 groups, the terrestrial planets and the gas giants. Drag and drop each planet into the correct box.
Okay, we said terrestrial planets are inner planets, yes. And gas giant planets are outer planets. Okay, now let's drag them. So the inner planets are Earth, Mars, Mercury, Venus, while the gas giants are Jupiter, Saturn, Uranus, and Neptune.
Great job!
Now, this question.
Which choices correctly describe the outer planets?
Outer planets.
Click all the correct answers.
Okay, do they have rings and many moons? Are they made of gases? They have few moons? They have solid surfaces? So the correct answers are these 2.
You got it. The outer planets have surfaces made of gas. The gas is condensed so much that it looks like a surface. Good job.
Okay.
Earth is
now
the
this
only
question.
planet in our solar system that supports life. What is it about Earth's place in the solar system that makes it possible for life to survive here? Type your response in the box and then click OK.
How does the location of Earth support life? How does the location of Earth support life? Think for a few seconds. Okay, let's see the answer.
Earth is just the right distance from the Sun so that it isn't too hot or too cold. Because Earth's orbit is almost exactly a circle, the temperature on Earth doesn't change very much throughout the year. Also, because Earth turns on its axis, sunlight reaches the entire surface. The existence of liquid water and Earth's solid surface are also important to life as we know it.
So the three reasons, okay? Now, let's go back to the book here. You have homework, you have to submit your homework, these pages. I hope it's useful. Good luck and stay safe.